Hi folks, this is the fifth tutorial that I'm preparing for a playlist which is called Elementary Structure Analysis Problems done with the 3D Experiences FEA module. Now, the first four tutorials, particularly the third one that I'm referring to, shows you how certain issues may arise that need to be addressed and in a very simple problem. Okay. And in tutorial 4, I propose one particular strategy, which is called impulse point functionality. And now I'm going to introduce you a different strategy, which is using a weld connector in the program. Now, here is the problem that we are looking at. And it's a very simple 2D frame problem, and the dimensions are given here on the right side. The material property is just steel. And what we like to do is to apply a force somewhere at this location, halfway between this vertical member. Okay. Now, what I'm going to do in this problem is create three lines, line 1, line 2, line 3. I'm not going to join that, okay? And because I'm not going to join them when it comes to meshing, there will be duplicate nodes at the juncture. And what I would like to do is to apply a force at this location. This is a very elementary problem, 2D frame problem, but I want to show you a particular strategy that allows us to do it the way I want to. Now, obviously, because this is a 2D frame, you can actually draw it in a sketch and start it from there. But what I'm going to do is instead do it as a wireframe in space. So this is my model made of 3 lines. And what I will do is, in order to basically put these two, because they're duplicate nodes here, I did not join them. I'm going to create a weld connection here, and I'll proceed from that point. Now, weld connection, when it comes, it asks you to select 2 supports. For example, I'm going to select the end of this line 1 as the support 1, and the end of line 2 at the bottom as support 2, and I'm going to change that to weld. Okay, this is going to be weld because there are many options that you got. I'm going to change that thing to weld. Okay, now just make sure that when you mesh these lines 3 times, because I don't want I want duplicate nodes. I don't want the node at the junction to be merged together. Make sure that this capture box is not checked, because if this capture box is checked to within the tolerance that you have here, to within a certain tolerance that you can find out what it is if you expand this thing, the 2 nodes are going to be merged. I don't want the nodes to be merged. Okay, so that's the first item. And the second one, just to remind you where the connectors are. Now, in the meshing, at the meshing stage, there are different tabs. Here's where you mesh, but this is something called connections tab. When you click on the connections, there's the connector, okay? And you create 2 connectors. They're going to be weld connector, 2 connectors. One is between the end of this line and that line, and a second connector between the end of this line and this line, okay? And just to remind you, when it comes to beam elements, you may want to be able to see some stuff on the screen, for example, the cross-section of the beam, etc., the axis or local axis system. Then this is the dialog box that you have to get into. In other words, right under the display tab, display preferences, and you change them. Okay, let's go ahead and do our problem. Because I'm not doing any joining, it doesn't matter whether if I don't need access to the join icon, therefore I can do things in the part design. Otherwise, if I needed join, I would have to switch to, for example, generative shape design, where the join icon is there. But I'm not doing that. Okay, so we have a part design. We have part design here, model. We're going to create 3 lines. So this is the first line, and it's going to be point and direction. So for the point, I'm going to create it because I don't have anything here yet. So 0, 0, 0 right there. And the direction is direction Z, 5 inches. All right. And then another line, again, 5 inches up. Another line, once again, point and direction. This is the point, and direction is Z, and still 5 inches. Okay. A third line, which is at an angle. So this is point is going to be this direction. Put the cursor there, right click, edit component. Okay. Put the cursor there, right click, edit component, and you can specify the direction. For example, if I say 1 and 1 here, it's going to be 45 direction sideways, and 5 inches. I want this thing to be 10 based on the geometry that I'm giving you. So there's my geometry. Now I'm not going to join these things. And when it comes to meshing, by the way, I'm not going to make sure that that checkbox is off so that I get duplicate nodes at the two ends, at the two sides. Okay. So let's apply our material properties. So tools. Actually, let me create one. So let me go ahead and create one. So under tools, material browser, not material browser, I want to create a material. And I'm going to call this thing tutorial 5. Tutorial 5. All right. So we'll create something by that name, but there are no numbers in it. So what we have to do is once it's created, which I believe is right here, we're going to select this and put it on that. And check the green arrow, green check mark. We don't need this thing anymore. Now we're going to input our value. So expand this thing, double click. So it's under structural, under Abacus Multiphysics, mechanical, elasticity. For elastic values, Young's modulus 29,000 KSI, 290,123 KSI. Poisson ratio, I don't need it, but I'll put down 0.3. And material has been created. Okay, now we're gonna go and mesh these things. Keep in mind that because my cross section is circular, I'm assuming circular, I don't need an orientation point. Otherwise, you're also probably better off if you create an orientation point and proceed. Now, to go to the measure, there's two ways you can do that. You can go here and actually go to structure model creation. That's one way of doing it. And that's how I'm going to do that. But the second way is to make sure you're at the top level, right click, insert a finite element model. But I'm going to go the first one. So, so go to this is called compass, to the left side, and structure model creation. Fine. It's an empty FEA model. All right. So here's the meshing tab right there, the meshing tab. Here's the beam mesher. You click on it. This box should be unchecked because otherwise any two nodes that are within certain tolerance, they're going to be merged. I don't want to be merged. Okay. So I'll do this one first, and 1 inch element size. So linear. So it's going to be 5 elements here, 5 elements there, and 10 elements there later on. So we say, okay. Notice that this is created right there. Another one for this fellow, same stuff. Make sure this is unchecked, and then 1 inch size, fine. And then this one, again, 1 inch size, unchecked. So there's going to be 3 sets of elements. Now, if you want to see these things, you go to the display. On the display preferences, you say, for example, I'm sorry, not here. If you want to see these things, you go to right-click Visibility Manager and say that don't show me the part, just show me the elements. So hide all the shapes. There we are. If you zoom in, you can see all the elements there. Element. Now, if you want to make sure that they are different as well as node numbers, what you need to do is to create be allowed to look at the numbers on the screen. So here's what I'm going to do. Numbering visualization. You put the cursor, for example, let's go to So if you want to see the nodes, if I put the cursor here, it says node 13. If you go from below, node 8. And halfway is over there. If you go from the top, node 7. If you go from the bottom, node 2. Okay. If that box was not checked and the tolerance was right, these are all going to be merged, which defeats the purpose of this tutorial. Okay, very good. Now, if you want to see your part again, just click on the eye and it's going to come back. Now, let's go and create our cross-section. So we go to properties, profile, beam profile, and it's going to be circular, and 0.5 is the radius of the 0.5 is the radius of the circle. All right. And now we're going to assign our section properties, beam section. If you can do these separately, particularly if they have different, for example, sizes, but because they have the same sizes, so I'm going to select all of them. 3 entities get selected, and the profile is beam profile 1. It shows that circle. Don't need an orientation point. I say okay. Now, if you want to see the actual effect, the three-dimensional effect, that's what this slide comes into the picture. You go to the display preferences, and for beam rendering style, don't say none. Say, for example, solid, or say sketch. Just the sketches over here. And if you don't want to, just say none. That's fine. Good. So let's proceed. I don't need this. We are done. We have to create our connector, right? Our welded connectors. Okay, so what we do, the connectors are done right here. And if you forget to do this thing, you move on, and then you have to come back to the measure in order to create those connectors. You click on the connections, and the one that we want is over here, connector, right there. 2 connectors. The support, the top point of this line, bottom point of that line, and another one is going to be top point of this line and the bottom point of that line. So you have to do these separately, and you have to do this thing patiently. Let me hide this thing for a second. So for the support 1, I'm going to select this point. Okay. And for the support 2, I hid it so I can go back there and select that. Okay. And the type is going to be weld. Okay. That's pretty much it. Now, you may be tempted to select as the first support that entire line and this entire line and make it weld. And if you run it, you'll see that this is not what you want. It's not what you want. It's point to point. All right, let's do another one. Here is the connectors that are being created. This is the first one. If you want, you can label it. And another one. Okay, so it's going to be, for example, that point for the first support. It's going to be this point, the end of this line. And for the second one, since the other guy is hiding, I'm going to select it right there. And then we say okay. Change the type to welding. Weld. And I say okay. So these are point-to-point connections. That's what it's called. So let's update this, see what happens. Good. No issues. This guy's in hiding, so if it's bothering you, you can just show it. Not that it matters. Now, good. So the next thing is you're going to go to structural scenario creation and select your finite element model. That's the one that I meshed. Good. On the procedures tab, do a static perturbation problem. This is a static problem. I just want to show you the process of doing this thing. So the easiest way is to assume it's static and linear, etc. But that means that instead of going static here, step, and just go static perturbation. It's just like the kind of thing that you do in an elementary finite element course, either theoretical or okay, that's good. It's all right. Now, boundary conditions, these are clamped. So we go to the boundary condition clamp, this guy and that guy. I don't think you're new to the 3D experience, but if you are, these are the other kind of type of boundary conditions you can apply. And then we're going to apply load here. Okay, now, so we go to load, force on that point. It's actually on that vertex. Now these are welded together. It doesn't matter which vertex you took, the top one or the bottom one. There won't be any issues. That's the whole purpose of creating a welded connection. 1,000 pound. Okay. And assuming that we haven't forgotten anything, and I don't think we have, let me put this thing in front of you because this is really a two-dimensional problem. So might as well look at it from the front. Where is this? Right there. Okay. And you go to simulate. Let's do a model and scenario check. Make sure that there are no issues, the obvious issues. Simulation check. There won't be any problems here either. I don't anticipate. But it's a good idea to do it to catch them early. And then once this is done, then we're going to simulate. Now, while this is doing its job, so in tutorial number 6, I'm going to propose a different strategy. And that different strategy is using the manual group to select a particular node that we want, okay? And then apply the load on that node, okay? So that's going to be tutorial number 6. That's almost finished. Yep. It is a good idea to go through these checks because sometimes things don't work out, and then at some you have to go and fix stuff, and then obviously this catches them early. Okay, this is done, and now we're going to simulate. Nothing fancy is going to happen. This is going to bulge out. So I showed you this business of connectors, at least a lot. This is very powerful. A lot of things can be done with connectors. And in other playlists, I will discuss more application of connectors. Actually, I have it in other playlists associated with 3D experience, but not in a systematic way. I mean, yeah. Okay, it's almost done. We will use this connector again later on when I do some elementary problem from structural analysis. Okay, that's pretty much done. And extracting results, you can see that. Nothing fancy. These are very basic problems. Okay, good. And there we are. Okay, so if you want, you can animate it, see what happens. You apply the load here, clamp, clamp. So it's very stiff. So it pushes this thing in, move this thing also to the right. And of course, if you want to slow it down, you go to slowing it down, and you can control it. All right, folks. So that takes care of this tutorial.